Welcome students, this is Professor P.P. Kulkarni. Today we are going to learn chapter number 5, Fundamentals of ENC System. In this chapter we will understand what is mean by a numerically controlled system, and the contents of the chapters are elements of ENC manufacturing system, concept of work zero and machine zero, then different types of ENC system we will learn, structure of ENC system, then different drives which are used in ENC system and their devices also, detailed steps in ENC manufacturing system, advantages of ENC manufacturing system, disadvantages of ENC manufacturing system, and then nowadays mostly used system that is called as a flexible manufacturing system. Elements of that flexible manufacturing system we will see, then application of FMS that we will see and at the last we will learn merits and demerits of flexible manufacturing system. So let us see one by one. First of all, understand what is ANSI system. A numerical control system is a system in which actions are controlled by direct insertion of numerical data at some point. This system must automatically interpret at least some portion of this data. In numerical control system, data is inserted and that data is in a form of numbers, letters and symbols. So we are going to learn part program in chapter number 8, and there we will see how these numbers, letters and symbols used in ENC systems. Today part programs can be generated directly by using CAD database ENC softwares. So for example, Delcam and Mastercams are softwares which are used for writing a part program or generating a part program automatically. Now let us see elements of ENC manufacturing system. There are three elements basically. First one is a program of instruction that is called as a part program. Second one is a machine control unit that controls the processes in manufacturing, and third one is the processing equipment, or you can call it as a tooling device. It performs all manufacturing operations. All these three elements, the first one is a part program, second one is a control machine control unit, and third one is a processing unit. All these three these are interconnected to each other, and by using these three elements we are going to manufacture a component in ENC system. Now let us understand what is a part program. A part program is a series of coded instructions which are required to produce a part. Now let us see here N10, G01, X 5.0, Y 2.5, F15. These letters, numbers and symbols are given. These are just one form for writing a part program. The coded instructions are composed of letters, numbers and symbols, and these are arranged in a sequence. Now let us see what is this N10. It is a sequence number. When you write a part program, N indicates line number of that part program. G01, it is a linear interpolation mode, but G is called G01, or G codes are called as a preparatory codes in part programming. Then X, Y, these are the coordinates. Also there is a Z coordinates that is used in the drilling operation. F indicates feed rate. It is shown here F15. So 15 is a value of feed rate and its unit is a inch per minute. Sometimes the units may change, it may be millimeter per minute. Now let us see, in part program there is a role of punched tape. So what is this punched tape? It is a medium to write a part program in ENC system. Its length is approximately 1 inch. NC machine system coding uses alphabet characters, numericals and other special symbols in part program, and this part program is coded on a punch tape. So whenever you write a part program for NC system, you need a punch tape. So this punch tape uses a punch card. Its a picture is shown in this figure. This is a punch card, you can see here. Then there are some pictures of punch tape. There are different types of punch tape. There are also advanced punch tape that you can see. This diagram shows punch tape reader. It is just like old days we were using tape recorders. These are the rollers, and over these rollers punch tape is mounted, and when these rollers rolls, then punch tape is read by a machine control unit, and accordingly it performs the operations. So in this photo, FANUC it is shown, FANUC. This FANUC is a name of a controller, and this right one and the left one both are the rollers over which punch tape is mounted. Therefore it is called as a punch tape reader. Now let us see a very important control unit that is called as a machine control unit in NC manufacturing system. So machine control unit is the heart of numerical control system. What is its function? It reads coded instructions one by one in a sequence. It decode coded instructions. It provide decoded information to control loops of the machine axis of a motion. It also control machine tool operations, and there are some advanced tape which are used to repeat a punched tape again and again, so that part program will be repeated again and again. Also there are some codes used in part program to repeat a part program whenever you manufacture a component. Let us see the next slide. Machine control unit, it has basically two components. First one is a data processing unit, and second one is a control loop unit. So DPU, what is its function? Data processing units, it reads a program, it decodes it, and it processes the information, and it passes to CLU. Once again I read, data processing unit, it reads a part program, it decodes the part program, means it releases instructions given in the part program, then it processes the information which is given in part program, then it passes the information to CLU. Now what is this CLU? CLU is a control loop unit. It converts the information to control a signals. CLU, it converts the information to control a signals, and it drives the mechanism which receives a feedback about position and velocity of the tool, and it instructs data processing unit to read new instructions. Means CLU works for implementing all the instructions given by DPU. Once again I repeat, CLU works for implementing all the instructions given by DPU. At the last, CLU, it instructs DPU to read the new instructions which is coded in a part program. So both are very important in machine control unit. Now let us see the next bit of this chapter. It is a concept of work 0 and machine 0. Both are very important to write a part program in the machine. So this is a diagram of a lathe machine. Here you can see this diagram. Work 0 it is shown, and machine 0 it is shown here. Now let us understand what is the work 0 and machine 0. I have shown this diagram by zooming it to just understand what is the location of work 0 and what is location of machine 0. Now you see here, machine 0 is a floating point in a space having a measure normally to accommodate a length of machine and maximum transverse length to each axis. So machine 0, it is not a fixed point. You can see this diagram. Machine 0 is not a fixed point. It is shown at a location here, but it may be at another location in a machine. So it is not a fixed point. But if you see a work 0 normally sets at a front face and at the center of a job. So you can see this diagram. Work 0, it is normally set at front face and center of the workpiece. So while writing a part program, we take offset in a machine, in a CNC machine we take offset, and this offset is taken with respect to a work 0 and we write a part program. So once again I repeat, what is a machine 0? Machine 0 is a floating point in a space having a measure normally to accommodate a length of machine and maximum transverse length to each axis. So machine 0, it is not a fixed point, it is a floating point and it may be at any place in a machine. And work 0, it is normally set at front face and at center of the job. So work 0 is important to write a part program. Sometimes in examination we are asked to write a part program, but their work 0 is not defined, so we have to assume this work 0. So work 0 you can take at the front face at the center of the job, or you can take at any space on the work. So work 0 you must assume on the surface of workpiece itself. So work 0 is important to write a part program. It is a reference positions to define a coordinate in a part program. Now let us see a types of ENC system, that is a classification of ENC system. First one is it is based on motion type, point to point ENC system, then straight cut ENC system, then contouring ENC system. Next is the based on positioning system, incremental ENC system, absolute ENC system. Then on the basis of control system, open loop control system and closed loop control system. And next one depends on power supply, electric power supply, hydraulic power supply or pneumatic power supply. So let us understand these types of ENC system one by one. So first one is a point to point ENC system, PTP. So in this point to point ENC system, so coordinates or workpiece moves from one point to another point in a linear motion. You can see this diagram. So these points indicates motion direction of workpiece. Each point has coordinates and tool moves from one point to another point to third to fourth to fifth. So these points are nothing but you can call it as a holes which are obtained by using a drilling tool, and this drilling tool drills the workpiece is mounted on the table. So tool moves from point to point. So whenever you go for the drilling operation, you need a point to point ENC system, one example I will tell you, convex drilling, it needs a point to point ENC system. Now let us see a straight cut ENC system. Straight cut ENC system is mostly used for milling operations. You can see this figure. In this figure, this is a milling tool, and there is a workpiece which is to be milled, and this spindle moves along the surface of the workpiece and you can mill the component. So you can see here the direction of milling tool, in which it moves, that is shown in this diagram. So this tool moves from this location to this location in a direction of C section. So milling operation will happen from straight cut NC system because tool is going to move in a straight direction along the surface of workpiece. Now let us see a contouring system. A contouring system, it is a very useful system as per the desired path, as per the will of a manufacturer or a user. You can move the tool in any direction. Suppose I want to move the tool in straight direction, you can move. You want to move the tool in a circular direction, you can move. If you want to move the tool from point to point also, you can move. So desired cutter path that you can obtain by using a contouring system. A special contour you have to define for milling or a drilling operation. So contour system is used for both. Here in the diagram I have shown here, only a milling operation is shown in this diagram, but it can be also used for a drilling operation or a slotting operation. For both operation, if you want to create a slot in a particular contour direction or in a desired path, you can use this contouring system option. Now let us see the next type, incremental and absolute positioning system. So both are very important for writing a part program. Mostly we write a part program in absolute positioning system. So what is the difference in between these two, absolute system and incremental system? Let us understand this. So here one table I have shown here. In the table there is a absolute system coordinates and there are incremental system. These are the increment system coordinates and these are the absolute system coordinates, and these are the whole positions A, B, C which are shown in this diagram. This is the position of A, this is position of B, and this is position of C. Now what happens actually, in the absolute coordinate system? Suppose this is a origin I have shown here. With respect to origin, coordinates of point A is written. With respect to origin, coordinates of point B is written. Similarly, with respect to origin, coordinates of point C are written. This happens in absolute coordinate system, but in incremental coordinate system, if you write a coordinates of point A with respect to origin, but while writing coordinates of point B, you should write the coordinates of point B with respect to point A. Means next point, while writing coordinates of next point, previous point should be a origin. Suppose in this diagram you want to write coordinates of point C, point B should be a origin. So previous point becomes origin and you can write the coordinates of next point. This is called as a incremental coordinate system. Both coordinate system mostly used for drilling operations only. You can see the difference exactly. In incremental coordinate system, x coordinate, y coordinates are written with respect to by assuming previous point as a origin. Now let us see absolute coordinate system. What are the advantages of absolute coordinate system, ACS? It is very easy to check and correct a program written. If there is any mistake in a particular block means it is a line in a part program. Line in a part program is called as a block. If there is a mistake in a particular block, it will affect only the incorrect dimension mentioned in that block. It means if you have written any wrong instruction in a part program, only that line will be affected. Complete part program will not be affected. The other part programs remains unaffected as all dimensions are referred with respect to only one origin. So for getting an accuracy in the part program, we should consider origin for writing each dimension. We should consider origin for writing each dimension. Fewer efforts are required while transforming actual component drawing to NC component drawing. Then let us see what is the advantage of incremental coordinate system. For complicated components like pockets and races, the dimensioning system is more advantageous. And what is the disadvantages? Positioning errors are compounded in incremental positioning system. If position error occurs, all subsequent points contains the accumulated error. What happens? We see this diagram once again. If there is a error in positioning tool at point B, definitely there will be a error in positioning a tool at point C. So if tool position becomes wrong, next point will be positioned wrongly. If tool position is wrongly positioned, then next point will become wrong. So incremental coordinate system, rather I will say, it is quite risky to write a part program in incremental coordinate system. So better way, we will write a part program in by using absolute coordinate system. For that purpose, G9090 is code is used, which is a preparatory code that we are going to learn in chapter number 8. Now let us see a next type of NC system on the basis of loop or control system, that is called as open loop control system. This is an open loop control system. Now in open loop control system, there are the components. First one is a tape reader, second is a machine control unit, stepper motor, gearbox, lead screw and work table. Now already we have seen the components of NC system which consist of a tape reader, which consists of machine control unit, which consists of stepper motor, a gearbox, work table, but there is no feedback system. Tape reader reads the instructions given on a punched tape, that is followed by machine control unit which controls the instruction, which reads the instructions given in a tape reader, and it controls the motion of stepper motor. Stepper motor controls the motion of gearbox, gearbox controls the motion of lead screw, and lead screw controls the horizontal motion of work table. But in open loop system, as per the given instruction, if work table is not moving as per the instruction, there is no feedback system or there is no signal system. This is the error happens. So there should be always calibration of output of these systems. In open loop systems, that does not happen. Work table does not give feedback to the machine control unit, so that machine control unit can improve the controls over the stepper motor, it can improve the control over gearbox. So that lacuna is covered by a closed loop system that we can see here. Closed loop system, let us understand first of all, then we will see the advantages and disadvantages of each system. In closed loop system, there is a tape reader. You can see there is a tape reader in closed loop system. Once again, there is a comparator, which is a new component incorporated in closed loop system, amplifier and signal processing unit, stepper motor, gearbox, machine tool movement. Now here you can see directly a machine tool movement, it gives a feedback to a comparator. Now what comparator does? Comparator compares the actual machine tool movement and given machine tool movement in a tape reader. If there is a little bit difference in actual motion and given motion, then it simplifies and once again a comparator passes the instruction to amplifier and signal processing unit. Once again stepper motor is rotated and it controls the gearbox motion, and once again machine tool movement is controlled. Is for example, machine tool movement is programmed as a 5 mm in a part program, but in actual there is a machine tool movement of 4.9 mm, so there is a error of 0.1 mm. So comparator compares this 5 mm and 4.9 mm, so there is a error of 0.1 mm. So comparator once again gives instruction to the amplifier and signal processing unit. It moves the stepper motor, it moves the gearbox, it rotates the gearbox, it operates the gearbox, and so that there will be a movement of machine tool by 0.1 mm. So remaining movement of 0.1 mm will happen by the instruction of only and only comparator. So comparator is a new component which is incorporated in closed loop system. Now let us see advantages and disadvantages of both the systems. First one is these are less costly. Open loop system is less costly. These are less complex. These are easier to maintain and popular with a smaller NC machines. Disadvantage is that there is no way to correct any error that may occur during operations because there is no feedback to controller. Just now I have discussed, if there is error of 0.1 mm, there is no chance to correct that error. Typically a lower torque motor is used in open loop closed system. Now let us see the advantages and disadvantages of closed loop system. Higher accuracy is achieved because of implementation of a comparator. Comparator is mounted in between tape reader and signal processing unit, as we have discussed. There is automatic compensation for error. As I told you, 0.1 error, 0.1 mm error is there, then it is compensated automatically. It is more preferred in large ENC machines because of the higher load. Disadvantage is that the systems are more complex and more expensive to buy and maintain. Now remaining part of this chapter we will see in a next video. All students are requested to watch the video and go through the test that I have uploaded on Google Classroom. Thank you very much for listening this lecture. You are requested to write your doubts in a Google Classroom. Thank you. Have a nice day.